Good morning. So today we will say some problems on vector algebra. Here we have the first problem. Find the work done in moving an object along a vector r bar equal to 6I cap plus 3j cap plus 4k cap if the applied force is given by F bar equal to 4I cap plus 3j cap minus 3k cap. So here we are given the force vector F bar to be equal to 4I cap plus 3j cap minus 3k cap, and the displacement vector R bar is given to be 6I cap plus 3j cap plus 4k cap. As we have seen that when we want to calculate the work done, which is a scalar quantity, though it is a scalar quantity, it is expressed as the dot product of two vectors, and the work done W is given by the dot product between the force vector and the displacement vector. So using these expressions for F bar and R bar here, we get F bar is 4I cap plus 3j cap minus 3k cap dot R bar is 6I cap plus 3j cap plus 4k cap. So this is equal to, we know that I dot I is 1, j dot j is 1, k dot k is 1, and rest of the dot products, that is I dot j, I dot k, j dot I, j dot k, and all those are 0. So the first term here is 4 into 6 is 24 into I dot I is 1 plus 3 into 3 is 9, j dot j is 1 minus 3 into 4 is 12, k dot k is 1. So this is equal to 21 units. The work done is 21 units. So that is how we can calculate the work done in displacing a certain object along a vector r bar given by this expression when the applied force on it is given by this expression. So that is how we can calculate the work done. Then see the second problem. Second problem is prove that the vectors given by A bar is equal to I cap plus 3j cap plus k cap, and B bar is equal to 2I cap plus 6j cap plus 2k cap are parallel to each other. We are asked to show that these two vectors A bar and B bar are parallel to each other. As we have seen while discussing the properties of dot product and cross product, that if the two vectors are parallel to each other, then the dot product is non-zero. But if the two vectors are perpendicular to each other, the dot product of such two vectors is 0. However, the cross product of two parallel vectors works out to be equal to 0 and the cross product of two parallel vectors is again non-zero and is 0, and if the two vectors are perpendicular to each other, then their cross product is non-zero. So here since we are asked to prove that the vectors a bar and b bar are parallel to each other, which means to say that we want to prove that the cross product of these two vectors is equal to 0. So let us evaluate the cross product of a bar and b bar. As we have seen earlier that the cross product of the two vectors a bar and b bar in terms of their rectangular components is expressed in the form of a determinant whose first row constitutes the unit vectors I, j, k. The second row represents the components of the first vector in the product, and the third row consists of the components of the second vector in the product. So using these vectors a bar and b bar here, we can express it as, so the first row is the unit vectors I, j, k. The second row is the components of the vector a bar, so it is 1, 3, 1, and the third row is the components of second vector in the product, that is 2, 6, 2. So if we evaluate this determinant, we can express it as I cap into bracket 6 minus 6 minus j cap into bracket 2 minus 2 plus k cap into bracket 6 minus 6. So this is equal to 0. So this 6 minus 6 is 0, 2 minus 2 is 0, 6 minus 6 is 0. So this is 0i minus 0j minus 0k, so it is 0. So since the cross product of a bar and b bar works out to be equal to 0, we can say that this implies that the vectors a bar and b bar are parallel to each other. Since a bar cross b bar is equal to 0, this implies that the vectors a bar and b bar are parallel to each other. So that is the second problem. Then we will see the next one. Find the scalar and vector product of e bar equal to 2i cap plus j cap plus k cap and b bar equal to 4i cap plus 2j cap minus k cap. Also find angle between a bar and b bar. Also you are asked to find out the angle between the two vectors a bar and b bar. So we are given these vectors a bar and b bar. So we are asked to calculate the scalar product of these two vectors and the vector product of these two vectors. and as well you are asked to find out the angle theta between these two vectors. So let us first evaluate the dot product of A bar and B bar. So A bar dot B bar is equal to 2I cap plus J cap plus K cap dot 4I cap plus 2J cap minus 3K cap. So this is equal to 4 into 2 is 8, 1 into 2 is 2, minus 3 into 1 is 3, so this is equal to 7. So A bar dot B bar works out to be equal to 7. Similarly, we can find out the cross product of A bar and B bar, that is vector product of A bar and B bar, which is given in the form of a determinant. The first row of the determinant is the unit vectors I, j, k. The second row is the components of the first vector in the product, that is 2, 1, 1. And the third row is the components of second vector in the product, that is 4, 2, minus 3. So this is equal to I cap into bracket minus 3 minus 2 minus J cap into bracket minus 6 minus 4 plus K cap into bracket 4 minus 4. So this works out to be minus 3 minus 2 is minus 5 I cap, minus 4 minus 6 is minus 10, minus minus will become plus, so it is plus 10 G, and 4 minus 4 is 0, so it is 0 K. So the cross product of two vectors works out to be equal to minus 5 I cap plus 10 J cap. So this is the cross product of the two given vectors A bar and B bar. Now we are asked to find out the angle theta between these two vectors A bar and B bar. So let us see how to obtain the angle theta between these vectors A bar and B bar. We have seen the definition of the scalar product of two vectors as A bar dot B bar is equal to A B cos theta. So from this we can obtain the expression for cos theta to be equal to A bar dot B bar upon A into B. Here A and B are the magnitudes of the vectors A bar and B bar. We have already evaluated the dot product of two vectors A bar and B bar, which is equal to 7. So let us first evaluate the magnitudes of the vectors A bar and B bar. So magnitude of the vector A bar, which is nothing but equal to A, is nothing but equal to under root of ax square plus ay square plus az square. So this is equal to under root. Ax is 2, its square is 4. Ay is 1, its square is 1. And az is again 1, so its square is 1. So this is equal to root 6. The modulus of the vector A bar, or the magnitude of the vector A bar, works out to be equal to root 6. Similarly, we can find out the magnitude of the vector B bar. Mod B bar is equal to under root bx square plus by square plus bz square. So bx is 4, so its square is 60. By is 2, its square is 4. And bz is minus 3, its square is plus 9. So this works out to be equal to 16 plus 4 is 20, 20 plus 9 is 29. So it is root 29. So mod A is root 6, mod B is root 29. So using these values of A, B and A bar dot B bar here, we shall get the value of cos theta. So cos theta is equal to, therefore cos theta is equal to A bar dot B bar divided by A into B. So this is equal to 7 divided by A is root 6 into B is root 29. So this is equal to 7 divided by under root 6 into 29. So this is 7 upon under root, it is 174. So this is the value of cos theta. Therefore, theta works out to be equal to, therefore theta is equal to cos inverse of 7 divided by under root 174. So this is the value of theta. So that is how we can obtain the value of theta, the angle between the two given vectors, by evaluating the magnitudes of the two vectors and the dot product between these two vectors. So that is how we can find out the scalar product, vector product and the angle theta between these two vectors E bar and B bar. So let us proceed to the next problem. Next problem is, determine the volume of parallel pipette defined by vectors A bar equal to 2i cap minus j cap minus k cap, B bar equal to I cap plus 2j cap minus 3k cap, and C bar is equal to 3i cap plus 2j cap plus 5k cap. So you are given these three vectors A bar, B bar and C bar, which constitutes a parallel pipette. All these three vectors originate from the single point, and these three vectors constitutes the three adjacent sides of this parallel pipette. So you are asked to find out this volume of this parallel pipette formed by these three vectors as three adjacent edges. So we have said that while discussing the geometrical interpretation of the scalar triple product of the three given vectors A bar, B bar and C bar, that the scalar triple product of the three vectors gives the volume of a parallel pipette formed by the three given vectors as the three adjacent edges. So we are saying that the scalar triple product of the three given vectors A bar, B bar and C bar is expressed as A bar dot B bar cross C bar. It is expressed as A bar dot B bar cross C bar. And this scalar triple product of the three vectors can as well be expressed in the form of a determinant of the components of the three given vectors. first row of the determinant is the components of the first vector in the product. The first vector in the product here is a bar, so its components are ax, ay, az. The second row of the determinant is the components of the second vector in the product, that is bx, by, bz, and the third row of the determinant constitutes the components of the third vector in the product, that is cx, cy, cz. So this is equal to. So using these expressions for the vectors a bar, b bar, and c bar, we can express the scalar triple product of these three vectors as the determinant of the components of these three vectors. The first row will be 2 minus 1 minus 1. The second row will be 1, 2 minus 3, and the third row will be 3, 2, 5. So if we solve this determinant, it works out to be 2 into bracket 10 minus of minus 6 is plus 6, minus of minus 1 into bracket 5 minus minus 9, so it is 5 plus 9 plus minus 1 into bracket 2 minus 6. So this is equal to 10 plus 6 is 16. 16 into 2 is 32. Minus minus will become plus. 5 plus 9 is 14. 2 minus 6 is minus 4. Minus 4 into minus 1 is plus 4. So this is equal to 10, 2, 3, 5, 50. Right? So the volume of this parallelepiped works out to be 50 units. So the volume of parallelepiped works out to be equal to 50 units. So that is how we can obtain the volume of the parallelepiped formed by the three vectors as the three adjacent sides, and the volume of this parallelepiped is nothing but the scalar triple product of the three given vectors. Okay. So I think this much is enough for today, and in the next video then we'll continue the remaining problems. Okay. Thank you.